Today we're looking at hard problem. We have a string with numbers. It's pretty long, 10 to the power 5 length, and have some t variable that is a modular divisor. Like we want to find the smallest number up from this string that is divisible by t. And it shouldn't have any zeros inside. Okay, this is kind of look as the same as yesterday easy problem when we have just a number, not a string, and we want to find the biggest number that is divisible by t. And in yesterday problem we just do it plus 9, because as soon as you go this plus 9 you meet this 0 divisible by t. However, in this problem we aren't allowed to have any zeros, so this trick wouldn't pass in this problem, and we have to do it wisely. I personally didn't solve this problem, but I tried to explain, because I first looked at this problem yesterday and today I wasn't able to solve it on my own. Some details were missing in my understanding, and I want to explain what are they. So the common trick, or maybe the base trick we will use here, is that we going from the t down, top down. Basically, to find that number is divisible by t, we are computing the number from this t, and to make it work we doing with like digits. Basically, if you divide t by GCD, greatest common divisor, t and some number x, this could be digit, this could be other number, but this doesn't matter. Basically, this formula allows us to say that basically we have some prefix, and we can distract this t by the digits of this prefix. So basically we go on t equal t divided by GCD with t and 1, then again t divided by GCD, t and 2, t and 3, and so on. So this is just, or maybe like 7 t and 7 GCD t, like this formula. And we saying that the entire prefix is a part removed from the t itself. Basically, if we go entire number, like we have total, and in the end we go from t, and if we in the end have just 1, that means the entire number was divisible by t. That's how it looks like. And if it's not that, then we have to find the some number greatest than this one. And if we have zeros, any zero, that's a trap. We should stop, because after zero all would be ones, and this is not correct. We have to make a t to make the main algorithm work, because this is our prefix, like prefix divisors, I would say. Basically, each position is a prefix that divides t and makes some result. So this is prefix equal t divided by GCD and this is, I'm sorry, this is not t, this is prefix I minus 1. This is prefix I minus 1, and this is string s I. So we're going from previous position to the current position one by one, and that means the value at this position is what's left from the t, left over. And so to the number be divisible by t entirely, the suffix should be divisible. Basically, this number, yes, so the suffix should be divisible by this number, not by the t, because t is shrank from our prefix. Okay, this is kind of, maybe you understand, maybe not. And the main algorithm is, imagine we have this long string, and we go in from the end and try to make it one up. So imagine the last digit is 3, we go with 4, and we're saying that we use this prefix I, we remove 4 from it with GCD trick, GCD EI 4, and we want to build the tail that is perfectly divisible by this number. This is what the algorithm, because our prefix is divisible. So basically we did t and we divided by each digit as we go. Then we shall build this tail, and by the way, we adjusted this with 4. We completely removed the 3 from our computation. This is removed, and we use 4 to align this leftover of t, and we must build this tail, and tail should be as small as possible, that this number is divisible by. So this is some sub problem. Build smallest number, by the way, it's string number, it can be big, that is divisible, that is divisible by some value. I would call it maybe t, also t, okay. So instead of just searching for how we can change the original number, we're doing what we're doing. remove some digit at position, make it one up, bigger, and then we build this tail. Completely discarded what we have in the original number we just built, and this tail should be divisible by what we have in the prefix of t left over. Okay, and to build this number, we going from 9 up to 2. By the way, keep in mind this is 2, not 1, because the 1 is tricky. And we going and we trying to place is this t divisible by 9? If it's not, skip. If it is, just do it, append while it's divisible. Append it, meaning prepend. So we're going 9, 9, 9. Then we go with the 8 is divisible by t divisible by, and by the way, we are adjusting the t equal divided by 9, and then by 8, so it will be 8, 9, 9. So we go and put in these numbers, digits to the left. After we're done, we doing padding to the length, because we are building this tail, and this tail should match exactly with what we had before in terms of length, because at most we doing one up, and this shouldn't change the length of number. So we have the length, and we either do a padding or we drop in this number if it is bigger. And by the way, we can suddenly have this t as a prime, and it wouldn't be divisible by any of these 2 up to 9. So in such a case, we should drop this 2, and this tail would be incorrect, and we have to move to the next to try it. And the final step, if no digit could be one-upped, we just go in one position to the left, and in this case we just build the tail entirely to match this t unchanged. Let's look at the code. So this is my code. Okay, I did several attempts to write it on my own, but I failed and asked the AI. Sorry. So GCD is correct function. This is p of the prefix. It goes, and this is crucial. If we meet 0, we should break, we should stop and don't pollute our p, because that would give us wrong results here. Okay. By the way, if we went up to the end, no zeros, and the p final p is 1, that means this n is divisible by t. Basically, we destructed this t. No, initial conditions of this prefix is t. This is crucial, pay attention, and we destructing it by each digit of the n string with GCD. I explained how GCD work before. So imagine we have numbers 12 and 8, and we want to destruct, or I don't know, decrease it by n by some digit 2. So we can do it like 12 divided by 2 divide equals 6, 6 divided by 2 equals 3, and 8 divided by 2 equal 4, 4 divided by 2 equal 2. And that means it's 2 times 2 times 2, and this is 2 times 2 times 3. And we can do it in one step instead of doing it in n steps. This could be shortened to just GCD of 12 and 8 is 2 by 2. This is GCD, greatest common divisor. It's common for them, and it's greatest possible. So it's 4. Okay, this is how we destructing or decreasing this t for each position and prefix. This is tail function that builds this tail that I talked about, and we gone up to 0 if we have 1. Because after 0, nothing is matters. We just build our own suffix. Nothing matters after 0. 0 is that cell. And we trying to one up the current position. Not just one up, I'm sorry, this is like entire range up to 9, not just one up. And we go and build the tail, adjust by this digit that we take, and we asking for this particular length to match what the suffix was. And if we have good length, we return the result, because that means we build the suffix perfectly divide what we have here, and prefix is perfectly divide what we have initially t, and then we make the pi. And if we didn't find anything, we just build the tail entirely with the length plus 1. Okay, we can look at maybe a little bit shorter version. This is it. It's still a wall of text, but this is how this problem is. By the time I looked at it, it was 14%. Yes, it is now 34%. Okay, that's it for today.